And I'm proud and honored to announce to you Christopher Pitt. Sorry. Chris, come here. Come here. I forgot something. And I want to do this publicly so it's documented for the whole world. Today, Ben Marks tweeted a little bit and he said, "Give Chris a hug from me." So here's your hug from Ben Marks, Chris.
Hello, thank you for being here. I can't really see everyone because lights, but I'm glad you're here. And yes, Niklas wasn't wrong. I am feeling very energetic today. So I'm going to ask if you wouldn't mind please standing just for a minute, if that's possible. Could you stand up? Thank you. You're allowed to hate me for this. You've probably had a delicious lunch outside. It looked amazing. And I don't want you falling asleep in this talk because it's just 40 minutes of pure fun. So we're going to do some exercises. If you're worried you're going to hurt yourself, please don't do this. Don't feel an obligation to. But we're going to do air squats. I'm not sure what the local name is for them. All you do, I'll demonstrate in case you've never seen them before, is you put your hands wherever you want. You can do this, and you go down and up. That's an air squat. We're going to do 10 of these, so I'll count us down in 3, 2, 1. 1, 2, 3, 4, 5. Wow, I am creaking. 6, 7, 8. Happy faces. 9, 10. Thank you very much. Please sit down. Right. Let me just turn the rain off here. Is that right? No. Toggle down 4. OK. No, it didn't work. OK, fine. We'll do it in the rain. That's all right. I get to talk to you today about, amongst other things, Minecraft. Before I get too deep into it, I would like to thank the organizers of Beyond Horizon for putting together this event. I've had a lot of fun today learning about all the new things coming in Shopware. And you flew me out from very far away. So thank you for that and giving me the opportunity to talk about what is probably not the kind of conference talk you expected to hear at a commerce-based community conference. So thank you for that. For all the organizers, in particular Niklas, because he's cool. This isn't PowerPoint. I'm sure you've seen lots of slide decks today that are in PowerPoint. And yes, I could use that or something similar to it, but I've chosen to do this within the context of a game because I think it'll make the experience more immersive for you. You'll discover as we go along why that's important, but for now, just be happy for the fact that this entire presentation is within a virtual world in a game called Minecraft. Now, I'm a huge fan of games when I get time and when I can play them with the kids and when I can play them with friends online. I really enjoy that. By show of hands, who of you play games or have played games before or enjoy that? OK, quite a few of you. That's awesome. I am a fan of the kinds of games that are very strategic. In fact, I happen to like games that are modeled around some of the concepts that we find in our day-to-day jobs with programming. Games that include a lot of logic or organization or debugging, if you will. And there are some really clear examples of games based on programming. There's one called Shenzhen.io, in which you play as a person who has a day job where they program. So you come home from your job and you load up this game and you're just a software technician in China, which is awesome. There are games that approach this more subtly. There's a game called Human Resources Machine. Hands up if you've heard of it or seen it. It's on Switch now. OK. Basically, Human Resources Machine is a kind of game where you solve logical problems. You have a very small set of language tools. And you climb the corporate ladder basically by solving more and more complex problems with a very limited set of instructions that you can give the game. Those are games based very heavily around programming and the concepts therein. There are some games which are a bit more subtle, like Factorio, where the goal of the game is to build the most efficient factory so that you can launch rockets into space. That's the end goal. And the bugs that you would find in software are personified in there as actual alien bugs that you have to squash. Minecraft is kind of dissimilar to all of those things and how it began and how it has grown. But before I talk about Minecraft specifically, I want to bring up the point that in 2017, it's estimated that free-to-play games alone on PC and mobile grossed $82 billion US. If you're interested in where those statistics come from, this is a link to the study that you can go and look at. I'll leave it up here for a few seconds. But I find that interesting because this is just the free-to-play market. This isn't the AAA games that you see advertised on TV or in newspapers. This is games where essentially the maker makes no money when the game is sold or for people playing on a month-to-month basis. They make money and leads to this total of $82 million estimated in 2017 just by cosmetic items or items that improve the experience of the person playing the game. And I think that's fascinating because there's no incentive for people to spend money except for that they're enjoying the game so much that they do. And this entire industry, come to find, is actually very successful. I think that's important to notice because there are a lot of people not just making these games or talking about them, but actually playing them. You know someone, pardon me, you know someone, even if you aren't a gamer yourself, you know a bunch of people that play games or that enjoy them. Games on iPad or iPhone or Android. And because you know these people, there's a trick I want to teach you. Now, let's jump back to Minecraft specifically. It was made quite a few years ago by a Swede with the name of Marcus Persson, or Notch, as you may have heard him referred to before. It's a game about primarily two things, mining and crafting, hence the name. He made it, and it turns out it was quite successful, and the company Mojang was then bought by Microsoft. So I guess you could say this is my first Microsoft tech stack talk. But I won't talk specifically about any Microsoft languages. I'll talk about the programming embedded within Minecraft itself. OK. Now, those two things that you can do, let me just get my controls up here. You can mine. So you can break blocks that you find in the world, whether they are parts of trees or dirt or cobblestone, and you can pick them up and then do things with them. I could put this block straight back down if I felt that it made a good decoration. I could put this block of iron ore into a furnace and smelt it into iron bars and use it to make tools or armor. I could combine this block with other blocks to make even more resources. That's mining. You'll find in games of Minecraft deep tunnels where players have gone to look for all sorts of precious gems and all sorts of resources that they can use to construct vast mansions and dungeons. The other aspect of Minecraft that makes up the name is the ability to take blocks that you harvest, these resource collectible blocks, and to convert them into other things. Like I can convert a log into 4 pieces of planks, and I can convert 2 planks into some sticks. The whole game is built around this ability to mine resources and to craft them into other resources. That's one half of why people play Minecraft, generally speaking. It's a game mode called Survival. And you can see if you look down at the bottom here, I have some, I guess, chicken legs that represent how hungry I am as a player. And in the game mode of Survival in Minecraft, you have to make sure that you're always fully fed. At nighttime in Survival in Minecraft, enemies spawn, zombies and skeletons and spiders, and they chase you. So a large part of the survival mode of Minecraft is just to stay alive. But there's another game mode that is equally interesting, and especially when the game was being made, this was the more popular game mode, which is called Creative. In Creative, you get into the game and you have every kind of resource available to you. Every block that you can harvest in the world, you have infinite amounts of them to be able to build incredibly large and intricate designs. And there are people who have run with this. They've recreated natural wonders of the world. They've started to map their cities and countries. There's even someone who made a 2-scale model of the Enterprise from the TV series Star Trek. And people do this. They make incredibly large and at times beautiful and definitely intricate things in Minecraft as a creative outlet. Now, whether you like to play survival or creative, doesn't matter to me. These days, the only time I open Minecraft is because of one other important thing in Minecraft, and it is redstone. It looks like this when you pick it up. It's deep underground, and so you have to dig tunnels and go and fetch it. But when you get it, you can use it to craft other redstone-like things. You can combine it with other materials like sticks, and you can create components from that, or you can put it down directly on a surface, like what I have done here. When you put it down on a surface, it starts to become like an electrical cable, or like the shiny lines on the underside of a circuit board. And so you get things in the... Hello? You get things in the game, in Minecraft, that emit electricity, if you want to call it that. Like this pressure plate over here. I'm actually just going to take my jacket off because it's making a noise on the mic. Go away. You get things in Minecraft that emit an electrical charge, if that's what you want to call it. This is an example of them. It's a pressure plate that the cow is demonstrating for us. When you stand on it, it emits a charge. And because this redstone is down on the ground next to it, the redstone will carry a charge. If I stand on it, this lights up, and you can see there's a lamp or a light bulb that lights up as a result of the charge getting to it. And this is all redstone was initially made for. The ability to put lamps or lights inside your house or your castle or your mansion or your dungeon, and to be able to control them using devices that would emit a charge that is then carried along redstone wire. There are various devices in the game like this that can emit a charge. A pressure plate like the one I'm standing on is one of them. There are switches, there are buttons, and they all have various different side effects. But this, and this alone, is the only reason I open up Minecraft these days. And to me, it's a really entertaining facet of the game. Let's take a step back for a moment and think about why we're here. Shopware and maybe more generally programming. And I want to propose to you that in Minecraft, using redstone and redstone devices, we can start to think about programming and even write programs. If you're a developer, you're probably familiar with code like this. Maybe you're into JavaScript or Ruby, and so the syntax might be slightly different there. But as developers, we are familiar with this kind of code. It's a conditional, or an if statement to be more specific. It takes a set of conditions and evaluates the truth in them. And if they are seen, if the statement is seen to be true, whatever is inside these curly brackets will be executed. In JavaScript, for instance, there aren't dollar signs. And maybe there are different keywords used for things like and, to say if this condition and this condition is true. But generally, programming languages have this kind of construct. If you're not a developer and you're here, thank you for being here. And you can think of this kind of as logical argumentation. This thing in front of me here has 4 legs and it moves. So it's probably a cow. If I'm drinking some coffee and it's bad, it's probably Starbucks. Starbucks isn't that bad. The point is, we depend on conditional statements like this a lot in code in general, and specifically in Shopware. There are all sorts of reasons why you would need preconditions to work out a postcondition. For instance, maybe we want to allow customers to edit their profiles. Well, when we're determining whether their profile form needs to commit something to the database, we have to say something like, is the customer authenticated? And do they have permission to make this change? If those 2 things are true, then persist the change. If one of those things isn't true, maybe we want to show them a validation error or take them to an entirely new error page. What if we're trying to allow someone to purchase an article on our application? Well, in that case, can their credit card be charged with the full amount? And are they allowed to purchase that for whatever legal or tax purposes? Do we allow them to purchase that article? If so, let them purchase it. You can start to get a sense of all the times we need conditionals in our applications everywhere. So what does this have to do with Minecraft? Well, in order to do Boolean logic like this, we have to craft a slightly more complex redstone component in Minecraft. It looks like this, and it's called a Redstone Torch. You can make it from combining redstone, dust that you pick up, with sticks that you make. And It's another one of those kinds of blocks that will emit a signal, or emit a current, or a charge, whatever you want to call it. The catch with the Redstone Torch is that it starts as always on. So you can put a line of redstone from a redstone torch to a lamp, and that lamp will be on. It has a quirk, though, and this quirk makes all the difference in programming in Minecraft. And it is that a redstone torch is on by default unless you send a charge into it. In this case, I'm putting a switch on. Stop it. I'm putting a switch on, and that charge is traveling along some redstone dust and into this block. And another side effect of Minecraft blocks is that the charge also gets pushed into this redstone torch. I could actually take this off and show you. Let me change this around a little bit so it's a little less confusing. Oh, that's not actually working. OK, anyway, I'll take it back to the original example. When the switch is on, this has charge, and so the redstone torch gets charge and turns itself off. And when the switch is off, the redstone torch turns on. Now, why is this useful? Let's take a step back and look at the examples again. The switch is another one of those devices that emits a charge, or a current, or electricity, however you want to call it. And that charge travels along redstone and lights up this lamp. When the switch is off, the lamp is off. When the switch is on, the lamp is on. What about if we look at this example? We can see that the redstone torch sends a charge into the lamp because it's on by default. But if we send the charge into the redstone torch, it switches off, and the lamp switches off. This tiny circuit here is basically saying, when the switch is on, the lamp should be off. And when the switch is off, the lamp should be on. Granted, it can maybe be made a little bit more compact, but you get the idea. Redstone torches in Minecraft act as signal inverters. It's sort of similar in programming when you say exclamation point in a variable. You're saying whatever is the opposite of the true value of that variable. That's what's happening here with the redstone torch. Now, that is kind of a strong programming concept. But there are other aspects to Minecraft which make it more of a good platform to emulate electronic circuitry, as opposed to just programming. In Minecraft, there is this concept of signal attenuation. Hands up if you've heard of that kind of term. OK, so one or two of you. And what that means is that from a power source, that power can only travel a certain distance before it travels no more and doesn't switch that lamp on. It's kind of a similar concept to Wi-Fi signal attenuation. When you are too far at home away from your Wi-Fi router, well, maybe you don't get a good signal, your speed isn't fast, or the connection keeps dropping. It's a similar concept to there, except instead of radio waves being attenuated over distance, this electrical charge is attenuated over distance because cabling factors. In Minecraft, it's about 17 or 16 blocks that a charge can travel before it completely dies out. And you can see it's very bright here. But as we go along, it gets duller and duller until it can't power this lamp anymore. Well, there's a Minecraft component called a repeater. And it does, similar to what it's named, repeat the signal, repeat the charge that's traveling along a wire. So now the lamp can be switched on because we've repeated the charge that goes there. And this is more of an electronic circuit design facet of Minecraft than it is a programming facet. The more and more I go on, the more you should start to see that there are these two concepts intertwined in how the components of Minecraft work. There's the programming side of things, which we'll come back to now, and then the electronic circuit design, which we've seen quite a few things of so far. Say we wanted to replicate the conditional expression that we saw in code a little while ago. But maybe instead of doing switch 1 is on and switch 2 is on, we could say something like if switch 1 is on or switch 2 is on. We could design that, we could design that in a circuit like this. Just some redstone going from a couple of switches and into a lamp. So if the one switch is on, the lamp is on. If the other switch is on, the lamp is on as well. And if they're both on, doesn't really matter. This is a Boolean or logic gate. OK, let's go back to our AND. So if switch 1 is on and switch 2 is on, how does that look? We might design it as something like this and take into account that inversion property that we saw redstone torches have. If both of these switches are off, both of these redstone torches will be on. And because this redstone here has a charge flowing through it, this one turns off and can't light the lamp up. If we turn just one of them on, that redstone torch goes off. But because this one is still on, that redstone still has a charge. And so that's still off. But when we turn both of them on, both of those torches are off. So there's no more charge in this redstone here. And that torch can turn on again. And the lamp can turn on. This is a logical AND gate. So we've got our OR gate over there. We've got our AND gate over here, which depends on signal inverters. And we saw over there, we've got signal inversion that we can use. That's a lot of programming just in redstone torches, right? I want to show you another programming-esque thing before we look at examples of how this stuff has actually been used. I've set up this little grid here, and what I wanted to do is show me where I am when I walk inside there. Ignore the logging text that you're going to see now, because it's actually doing a lot of operations in the background. But have a look when I move in here. There's my player name and my position within the map. If I move to here, you'll see that value changed. I can move to the middle. I can stand over here. Those values change all the time. Now, the command that's allowing me to do that is one that's built into Minecraft. I'm not doing it the way you might think I am, though. There are components in Minecraft called command blocks, and you can put player commands inside of them to be able to detect things and do things in your Minecraft map. I'm using one of those commands, but I'm actually connecting to this map from a PHP script. And I want to show you how I'm doing that so you can further appreciate what Minecraft lets you do. I've set up a very simple set of classes. You don't really need to worry about what I'm doing in most of them. But what I've done is I've defined a grid of blocks which include all the ones I can step into inside of this fenced area. So the one in the top left corner, I guess, starts at -337. Don't worry so much about the offsets, but you'll be able to see what's going on here. -337, X coordinate, and 444, Z coordinate. And that is the one corner. And then the opposite corner is -333, X coordinate, and 448, Z coordinate. It's a 5 by 5 grid inclusive. Then, let me scroll down to here. When I run this PHP script, I'm going through each of the coordinate arrays within that grid property that I defined and dereferencing the X, Y, and Z coordinates from them. Then I'm detecting a player at that exact position. And if a player is detected, then I'm updating the sign that you saw with the player's name and the player's coordinates. This is the coordinates of the sign itself. In order to detect the player's presence, I use this command, test for all at these coordinates. Now, as I said, you can run these commands directly in Minecraft, and you will see the output of them. And you can use similar commands to modify the Minecraft world. When Minecraft is run with a dedicated multiplayer server, it actually also spins up an administrative command server on a protocol called Rcon. Maybe one or two have heard of that in the past. It's exactly the same administrative command protocol as runs in the game Rust, or as used to run in the game Counter-Strike. So it's a fairly common protocol in those standards, I guess. And it allows us to issue the same kinds of Minecraft commands we could do in the game from outside, in this case, inside a PHP script. Why does this matter? Why am I telling you about this? Well, maybe you're starting to get the idea that this entire virtual map has a coordinate system, that every block I can stand in every block of dirt or block of cobble walk fits within that coordinate system. And as a player, I can actually enable the debug console. Now, there's a lot of info in here. Don't freak out. What you want to do is you want to look over here. You see where my mouse is? X, Y, and Z. These 3 coordinates. I have to show it in the pause menu because otherwise I'm just going to look in a different direction. Have a look what happens to the 3rd number there, the Z coordinate. It's currently 451. And if I move along this axis, you can see it increases and decreases. Now have a look at the leftmost value. It's currently -336. And if I travel in this direction, you can see it gets more and less. And just for the sake of completeness, watch the middle value, the Y value, when I jump. It gets a little bit more, and then it decreases again as I come back to the ground. This is really important because if every block in this map has a coordinate and can have another block or a player inside it, it's actually a giant block of memory. It's a giant bit of RAM. And the coordinates that we use to reference specific positions inside of it are like memory references. We don't just have the ability to test for the presence of a player, we can test for the presence of any kind of block and any kind of block configuration data as well. So a map of Minecraft is a huge amount of RAM, especially given since Minecraft maps are made to be infinitely scrollable. Not in the technical sense, but in the practical sense, you'll never walk to the end of it. Okay. Hopefully by now you have some idea of the scope of programming you are able to do inside a Minecraft world. And people have taken these concepts and they've used it to build really incredible things. There's a map I won't open up because it's actually quite slow on my machine. And it looks like this. Someone's built a computer with a screen and a keyboard and a mouse in a Minecraft map. You can press any of the keys on the keyboard and see those values reflected on the screen. And really, the back of it's actually quite a mess of logic gates and of command blocks. There's a lot of redstone going on here. And I don't really understand it. I've sort of gathered where the general regions of it are, but there's a lot going on here. Technically, it's able to do this kind of mathematical operations, including calculating the squares of numbers. More experientially, though, it can play 3 music tracks that you can pick from the media player. It can play 3 games, including Hangman and Tic-Tac-Toe. And the Tic-Tac-Toe actually has AI, so you can play against the computer. It's got 14 bytes of memory that you can customize the content of to store and retrieve as you wish. And as I mentioned, it's got a fully working keyboard and mouse. You can manipulate the mouse to move where that cursor points to, and you can click the button on the mouse. It's actually quite cool. This is a very programming-oriented application of the components that we've seen in Minecraft, but it's not limited to that. Because Minecraft models electronic circuitry so well, it kind of opens up the ability for us to connect it to real-world hardware. A couple of years ago, I wrote a series of articles for an educational website called SitePoint, sitepoint.com, if you want to go have a look. And these articles span the full breadth of PHP and Minecraft and circuitry. What I did was I explained how to make a door for your house or your mansion or your dungeon. And then I also explained how to make a couple of circuits connected to this door or watching this door. So when the door was open, one of the circuits told me, hey, the door's open. And when the door's closed, another one of the circuits told me, hey, the door's closed. It probably didn't do it as animated as that. But what I was then able to do was watch for those changes in a PHP script. In exactly the same PHP script, I connected to an Arduino. Now, if you're unfamiliar, an Arduino is kind of like a hobby electronics, easy to get into circuit board. It allows you to detect things from sensors in the real world and change things to components in the real world. To give you an example, you could have a sound sensor. So when you clap, an LED lights up, connected to this Arduino. And so I made this door with its detectors connect to the PHP script to tell the PHP script when the door was open. And then I made the PHP script connect to an Arduino board and to light up a light or to sound an alarm when the door was open. It was a real-world alarm system for an in-game door. It's perhaps not the most useful example of what you would do connecting electronics to Minecraft, but it was actually pretty fun to write. You can have a look at the post. I don't know if you're going to see the URL over here, so you can have a look over there. There's the short link. But the post is also pretty helpful in terms of explaining electronic components from beginning to end for making this example. So it talks about LEDs and resistors and the buzzer that I used and Arduino, and it has circuit diagrams. So you don't need to know any electronics or really a lot of complex PHP to be able to follow along with this tutorial. You can find it at this link. I've got a few other ones there about Minecraft and programming if you're interested. OK, I will move away from this in 3, 2, 1. OK, let's talk about what this has to do with Shopware, because that's why we're here, right? Shopware. I wondered if it would be possible to connect to a local Shopware application and to be able to pull data into Minecraft from that and push data out to Shopware from within Minecraft. I made a few custom commands in Minecraft. So I can say something like !shop, and it'll tell me, hey, we need an email address first. OK, fine. I need to do some kind of pseudo authentication. So now I can say something like email, foo@bar.com. Only what it's doing is it's checking my email address against the one that I've registered on my local Shopware application. I have to type the email address of a registered user in order to authenticate, pseudo-authenticate, inside Minecraft. I'm going to show you the code to do that, because I think the code's kind of interesting. Here is this Shopware instance that I've created. I took 5.4. Let me log in and see if I can see the version, specific version. OK, no, fine. It's 5.4.2, I think. I set up this application following the developer docs. I installed the demo content plugin, which is why there are some products in here. And I registered an account so that I could validate my email address inside Minecraft. Then I went to the developer docs again, and I looked for the code there to be able to do simple requests with the current JSON API. This is almost exactly the class that you will see in the developer docs. I've made some style changes to it, just because I'm pedantic like that. And I've also replaced the prepare response method that the docs suggest just with a JSON decode, because the JSON API is going to return me well-formatted JSON, even if there are errors in my request. So inside my game, I can make a custom command. Let me scroll down to where it is. I can make a custom command called shop, which will check if the user has authenticated, pseudo-authenticated. And if not, it'll tell me the command I should use in order to authenticate. Then when I type that email command, I can filter based on the email address. I get this command which just tells me !email, or actually it just tells me email space and the email address. And then I can use that as a filtered parameter when I call the /API/users endpoint. So I will get a list of all users with exactly the right email address that I've authenticated with inside Minecraft. If it's not successful or I don't have any rows, well, email's not found. There's where the validation happens. If it is successful, I tell the user, OK, it's successful. And then I store that credential for reasons I'll explain in a little bit. Now, I've authenticated in the game, so I should be able to shop, right? I can't actually get in here until I've authenticated and then typed shop so that it opens the door for me. Because I don't want users in here that aren't authenticated, right? They can't actually purchase anything. It'll close the door behind me, so I've got to buy something or I'll never get out. OK, this shop is empty. There are no products here. Well, I've made a custom command called refresh. And that goes and fetches the four most recently. Oh, it's not showing a fourth one. That's interesting. Let me try that again. OK, it found the fourth one somewhere. It shows me the four most recently updated products in my local Shopware application. In case you are doubtful that this is a dynamic thing that's happening here, not only will I show you the code, but I'll update a product so you can see that it's dependent on recency. Let's go down here to what looks like the oldest product, and let's give it a funny name like 123 Shop. Just as an example. It's a silly example, but there we go. When we go back into the game and we refresh again, we can see the new product with its dynamic name. So we're fetching dynamic rows from the Shopware application, right? Let me show you what that code looks like. When I refresh, then I fetch limited to 4 articles from the Shopware application, and I can sort them by recency. I've defined a private property which shows 4 coordinates for each, let me tab back into Minecraft, for each of these signs on the wall. Those are their coordinates. So I've predefined that ahead of time. I can scroll back down to refresh. So I get my 4 products, the most recently updated ones. I loop through each of them, and then I dereference a coordinate point based on the coordinates array I set up initially. So this will be this product 0, this product's 1, this product's 2. Then I fetch the details of the product because the price, and in fact main detail, isn't immediately displayed when you do /API/articles. You have to do an ID lookup, unless I'm doing this wrong or not having the correct query string parameter in. This was the way I found to do it. So I can fetch the name from the original product lookup, but then I can also fetch the price. And you could do calculations on this, or you could fetch a different field. But for illustration purposes, I get the first price value I can find, and I format it to 2 decimal places. And then I update the sign that is on the wall. That's how I get my products into Minecraft. Now, you will not believe the amount of time I spent trying to get a purchase to go through in this map. The best that we can do in 5.4.2 is knowing the user's email address and knowing the product's ID. We can create an order, and then the user can go based on payment methods that you set up in your app and pay for the order at a later stage. But what I try to do is simulate a browser and have the user go through a form to log in, and wow, it was quite a mission to try and do. With the new core stuff that we saw this morning, having the ability to authenticate a user, to add credit card details, and to check out a shopping cart full of products, we could, at that point, extend this map to allow people to do all of their transactions inside a Minecraft map. We'd obviously have to take extra security that those details that are sensitive aren't logged, that they can't be seen by other players, but it's entirely possible for us to run the entire shopping experience inside a Minecraft map, given a sufficiently advanced API, which is certainly coming to core. So that's the adventure. That's how I got Shopware data into Minecraft, and how I sent data out of Minecraft to Shopware. Now, I will show my tweet screen, or my Twitter screen, quickly. And while I'm showing you this, I want to talk about the entire purpose of this talk. There are 2 important things I want you to remember. Whether you're a developer or someone who works with developers, you may, like I had for the longest time, have a very narrow concept of where your developers are coming from. Perhaps most of them, you feel, come from being self-taught. So they leave high school, they do a bit of studying in perhaps an unrelated field, but they teach themselves how to develop, how to program. And so maybe that's where you expect developers to come from. Or maybe they studied at a university to be able to program, and that's where you expect them to come from. I've gone through this entire map and showed you very little PHP. Most of the programming I've showed you has been inside Minecraft. And that's because Minecraft is essentially a Turing-complete programming language and environment. You can use Minecraft that maybe your kids or family members are playing to teach them about the basic concepts of programming and electronic circuitry. And here's the thing, it's not a classroom environment for them. They're already having fun inside the game. Now you can show them, hey, did you know there's this little thing you can do with Redstone, and poof, now they know programming. Now they know electronic circuitry. It's a beginning. Surely they're not going to make the next lunar lander based on Minecraft electronics. Actually, maybe they do. But this is an unobvious teaching environment for people. And I can't wait for my kids to get the attention spans to be able to start doing this kind of stuff so I can walk them through electronic circuit design and programming inside Minecraft. That's the one of the, but the most important point that I want you to take away from this. Your developers aren't just coming from being self-taught or just coming from studying at a university. They're coming from all spheres of life. And gaming, as we saw, being an $82 billion industry for just free-to-play games, there are a lot of potential developers there. Maybe you're not a developer and you want to learn, and this looks like an interesting place to start. Can I encourage you to do that? Can I encourage you to try and start programming by just tinkering around with what you see in Minecraft? The second and slightly less important point that I want to make is that there are many potential customers already in the sales channel. Are you marketing to them? You've seen how we can bring data from Shopware into Minecraft, and we can do it in loads of other games. It's possibly easier in other games as well. There are all these potential customers who aren't going to your online shop. But as we heard from the keynote this morning, online shop is just one of the many places that can start to bring in new customers and start to work as marketing channels for your services and products. So, those two things. We're almost out of time. And I want to show something cool, so I'll show it afterwards if anyone's interested down there. But would you like to take over?
Yes. Oh, yeah, now I'm here. Well, first of all, thank you, Chris. I actually didn't know what you were going to show. I just knew about Minecraft, and I think he deserves a little bit of applause, doesn't he? Go on, go on. Thank you. Okay, and you're all developers. Who's not a developer? Oh, well, okay, it's not for you, but the rest of you. You heard about the Shopware playground, and I expect you, at least one of you can decide among you who is it, one of you has to build a playground Minecraft experiment. Okay, can we do this? This fall, you, Minecraft, would be awesome. Okay, Chris, well, thank you for your talk, and I want to start the QA. When you have questions, you will raise your hand, and then I will come to you with a microphone. But first, I have a question on my own. The whole point of your talk, so far that I grasped it, was that you want to enable people to go into programming or to teach their people programming without the people who are learning even knowing that they are learning programming, right? Okay, okay. That's a yes, he's nodding. Okay. Why Minecraft? There are games that are more beautiful. There are people who the original developer doesn't come across as a jerk. I mean, nothing against Notch, but sometimes he's a little bit, you know. So why Minecraft? Why that? I mean, it's ugly.
I really like Minecraft. I think it's a very good broad spectrum which approaches programming and electronic circuits, and I think that's really cool. When you can see the full gamut of environments in which people can think about code and think about robots, that's a really useful thing for me. It's important for us to be able to love something and still be critical of its origins or its intentions or its uses. And I think if we're careful about the message that we portray and that we highlight the good and bring down or ignore the bad, or however we approach that, that we can still use this for a lot of good, that we can still teach people and have fun being creative in this without specifically dwelling or praising the bad in the community.
Focus on the good. That's a very nice answer. So, anyone has a question for Chris? No questions, just awesome. Okay, so when there are no more questions,
Can I show the thing?
Yeah, then you can show a thing and then...
So I was remembering a thing I made a little while ago, and this morning, and so in a little bit of free time earlier, I put it together again. I wanted to, at a stage, I wanted to make an Arduino project that was just a wall of LEDs that I could program to make shapes and patterns and things. And there are a number of ways to, maybe I should take a step back. Depending on the model of Arduino that you have, you only have a certain number of outputs on your board. So some of the smaller boards, it's maybe 5. Some of the bigger boards, it's maybe 15. And so if you want to do a big LED matrix, well, you quickly get a lot of outputs that you need to map to. And you can't plug all of them directly into the Arduino. So there are a number of approaches to get around this limitation of scale. And one of the slightly older approaches uses a chip that resembles this thing. It's commonly known as a 4051 multiplexer chip. And the way that it works is that it has 3 pins for binary input, and it outputs to 8 different outputs. So you get an expansion of 3 outputs on the Arduino to 8 outputs for your LEDs. You can chain these so that 3 of these multiplexer chips speak to another multiplexer chip, and then you start to get an exponential growth of outputs on the Arduino to outputs in your circuit that you want to make. Okay, I don't want it to go that far and be too complex there. But what was interesting to me when I started learning about this stuff in Minecraft was that I immediately thought of this, because all this chip is a whole lot of AND logical gates. It's checking the input of 3 binary pins, so on or off, on 3 different pins, and using AND Boolean logic to determine which of the outputs should be switched on at any time. Come to find, you can represent this entire circuit, this entire chip, inside Minecraft. And this is another example of how closely Minecraft maps to electronics as opposed to programming. I've got my 3 switches down here, and I'll switch all of them off. When you switch the 3 logic pins of the 4051 multiplexer off, then the very first input on the chip is switched on. You actually have to turn off the input in order to switch all of the pins off. And I've kind of simulated that here. All 3 of these switches are off, and that first light is on. That first output is on. If we go from right to left, like good binary does, and we switch this value on, it's going to switch the next light on. OK, the next, if 001, if 000 is binary 1, and 001 is binary 2, then what is binary 3? Any suggestions? You're going to have to shout it. I can't hear you if you're saying it. Go 000, 001, 010. So let's do that. 010. That's the third one. Then it goes 011. That's the fourth one. Then it goes 100. That's the fifth one. 101. That's the sixth one. 110 is the seventh. And 111 is the eighth. This is the multiplexer chip in Minecraft. It's only done with AND gates. Because we have 3 inputs, we need 2 AND gates. We'll say, take the first 2 signals and compare them, and then take the result of that in the next signal and compare them. Where we expect the inputs to be on, no, let me change how I'm talking about this. Let's say in the case that we're not giving a signal to any of the logic pins, the first output will be on. So we're saying if all of these switches are off, invert their signals and use those in AND gates in order to switch this on. Where we expect a 001, invert the first 2 signals that we expect to be off and leave the third signal on. It's basically just a whole combination of AND gates and signal inversion to be able to recreate a 4051 multiplexer chip inside Minecraft with no external commands, no complex internal commands, just logical gates and signal inversion. There are some repeaters here just to make sure that the signal travels all the way to the end of the circuit. And one thing that's interesting to note here is that this is, for the simple thing it's doing, quite a large circuit. Minecraft circuits tend to be huge and expansive because essentially we're storing the data and the programming in one place. I was saying to Niklas earlier, the thought occurred to me, because the commands can be stored inside blocks inside Minecraft in a memory map, it's almost like programming in Minecraft is more like smart contracts stored on a blockchain than it is a programming language executing against memory. But anyway, this was just a silly little example I worked on earlier. Are there any questions about this? All right, I think I'm well out of time. So thank you.